So now it's my turn to present to you the work that we have been conducting at ADAI and my group over the past 6 months. We have been conducting, as the name indicates, exploratory trials. Why exploratory? Well, we are trying to assay what path we are going to choose, in which direction we want to head. And this is why we have been conducting several exploratory trials and the coordination of Mr. David Caballero, the previous speaker. I would also like to thank my colleagues Jorge Raposo and Ricardo Oliveira for their support in conducting these trials in the lab. So I'll try to do my best to describe as well as possible the trials that we have been conducting. We don't really need a detailed introduction because the members of this group are very well known, know very well the problem that wildfires pose to communities. As David mentioned, this has been the subject of discussion not only here in Portugal or in Spain, but worldwide. And the question of whether people should leave their homes or stay in their homes and protect themselves has been the subject of much heated debate. There are those who support that people should leave their homes, run away. Others believe that they should stay in their homes. But we do know that the safety of a home often depends on the owner and also depends on the construction materials, how the building has been maintained, topography, if it is located at the bottom of in a valley, at the top of a hill, etc. So all of these are questions that determine the fact that a building is hit or not by wildfire. And all of these issues we are studying in our lab. For several years, we have been conducting trials on the resistance of rooftops to wildfires, and currently we're testing other structures. It is also important to understand the mechanisms related to a fire that can prevent a home from igniting. These are linked to the properties of fire, one of which is conduction. Here we have a match, a lighted match. The fact is that conduction is very rare in homes. It will require exposure to fire, to the flame, over a long period of time, but it can happen. Radiation can also occur, and it is proportional to intensity, distance, the length of the flame. For example, this home is a wooden home, and yet it managed to survive a wildfire. Convection is also very seldom, and it also requires contact with flame. Even so, we know that the most common way of a home igniting and of having some of the elements igniting is through some fire through the effect of some fired elements like these. Windows are normally the elements that are most exposed, be they or have they shutters or not. In general, windows are the most vulnerable spots of homes, and for that reason we have dedicated most of our trials to windows. The general objective was to assay the main parameters or the main structures of a home that are most vulnerable in the case of fire. And our intention was to understand a phenomena like this. This was the general objective. The specific purposes of our trials were to assess the resistance of different types of shutters to the impact of a fire front, to compare the effect of radiation and convection, and also another phenomenon, which is the influence of the opening of inside doors and windows and their exposure to currents. Unlike what is usual, normally we conduct field trials after lab trials. We took the opportunity of field trials that were being conducted in Castanheira de Pera, and we took this opportunity to conduct field trials first, to in particular shutters and the effect or the impact of fire on these, and only afterwards that we carry out some trials in our labs. This was the first stage of our trials that were conducted on the field. This is an area that is well characterized. We conducted them on a typical day, on a typical spring day. The vegetation was studied, listed. These paths were had been opened up in previous years, and our plots are the ones that you see on the upper drawing. So what we did was to put on the field two shutters, one in PVC, one aluminium with polyurethane filling. And then we installed in one of the shutters a flow measure. And obviously our system for collecting information had to be protected, so we assembled a fire shelter over our computers, and we ignited a fire at the bottom of the hill and waited for it to spread to the shutters. What we could see was that radiation reached 300 kilowatts per square meter. So it's not very high radiation, but enough to meet our intentions. And the shutters were exposed to a temperature of 350 degrees Celsius. From 150 degrees Celsius, the PVC started to melt, and it melted entirely onto the ground. And this is where radiation peaks discharged. But the temperature in the aluminium shutter reached 150 degrees Celsius. Here you can see these are the general characteristics of the fire. We filmed the different stages. The bottom film was using an infrared camera, and also filming from close. And as you can see, the PVC shutter melted completely. This was the result. Although the fire was not very intense, it was actually 30 times more intense than we could obtain in a lab. But you can see that the PVC shutter did not resist the fire, but it did not inflame, nor did it melted, but did not form drops. And dripping is very important because otherwise it could have inflamed other elements. But the fact is they melted, and they simply melted onto the ground and stayed where they were. It did not spread or splash. The aluminum shutters with polyurethane essentially remained intact throughout the fire. In the lab stage, what we did was focus more specifically on three aspects. First, the resistance of windows and shutters as a whole, because we did not test the windows on the field, followed by the influence of indoor and outdoor openings in the passing of air. We tried to address questions when we did not manage to reply to all of them entirely. We managed to obtain some kind of response, but we realized that we still need to do more work before we can understand all of these mechanisms. Nonetheless, these were our departing questions. Can shutters be enough to protect a passing fire, and what type of windows should we use? Double glass, single glass, and based on these questions, we conducted these different tests in the lab. We used different types of shutters: PVC, aluminium with polyurethane filling, and wooden shutters. And we tested these on the two types of windows. We tested all of this with thermocouples and also with a flow measurer. Initially, we thought that we could also measure temperature inside the window frame, because the frame sometimes can break under the pressure of high temperatures. But sometimes windows do not occupy the whole space inside the frame, and sometimes the frames are filled in with silicone, and that could also influence the results, we realized. And these were the parameters that we measured: temperatures on both sides of the window, temperatures on both sides of the shutters, and the heat flow and the effect of the heat flow on the shutters. And we also used two sources of emission: a radiation panel over 5 minutes and real fire. This is just to show how we codified the tests. We have double glass and single glass windows with shutters and also without shutters. So we also conducted tests without any kind of protection. This is how we assembled the devices. We assembled a frame like the one you see here, and then we mounted the windows without shutters with the different types of shutters, and we conducted the measurements. Very briefly, these were the results, but many of these results we are still analyzing. But I will not go into too much detail. I would prefer to focus on the conclusions that we have managed to draw from the trials. Anyhow, the radiation that we managed to obtain with the panel was 1.5 kilowatts per square meters, and the temperature of the window temperature, every time whenever protected by the shutter, only reaches 30 degrees Celsius. Unprotected windows, the temperature of unprotected windows increased at a constant pace. So for as long as it is submitted to heat, temperature will continue to rise. The temperatures of the shutters. The PVC shutter possibly absorbed more heat, and the temperature reached as high as 90 degrees Celsius. But if we replace the radiation panel with a fire of natural origin, so from natural elements, we would have a radiation of 10 to 20 kilowatts per square meter, but the temperatures doubled. They doubled in the exposed face of the shutter, while the window temperatures remained around the same, 30 degrees Celsius. So this suggests that shutters managed to protect the windows, with the exception of the PVC shutter that once again melted. It did not melt entirely because meanwhile the trials ended, but at 150 degrees Celsius, once again, the PVC shutter melted. We are talking here about single glass windows. And when the shutters melted, you can see that the window temperature started to increase. So it suggests that shutters do play a very important part in protecting the window. Now, moving to double glass windows. Here you can see that temperature ranges around 10 degrees Celsius, depending on the window, the glass that is exposed to the fire, or the indoor glass pane that is not directly exposed to the fire. But the parameters or the values obtained on the shutters are very similar to the values obtained in the previous trial with a single glass window. Here you can also see that without the shutter, the glass that is exposed to radiation, the temperature there increases from 30 to 50 degrees Celsius, but the temperature of the indoor window, the indoor glass, does not increase. The temperature does not increase. So quite clearly, double glass windows offer greater protection than single glass windows. And although the space between the two is only 1 centimeter, clearly there is a big difference in the temperatures of the indoor glass and the glass that is exposed directly to the fire. Once again, the effects on the shutters are more or less the same. The PVC shutter melts, and the indoor glass continues to be protected, maintaining a temperature of around 30 to 40 degrees Celsius. PVC only resisted and did not melt when with the radiation trials, where temperature was so low that it didn't cause almost any impact. So consequently, we can say that both aluminium and wood shutters resist high temperatures. We used pine wood non-treated shutters. But even in the treated wood, we saw that the covering melted, but temperature remained more or less the same. And we may also conclude that PVC shutters start melting at a temperature of 150 degrees Celsius. You can see here that this home resisted fire that even didn't even come very close to the home, and yet the PVC shutter melted, as you can see from the picture. What we wanted to understand from these trials was if we have a room with a window and a door on opposite ends, if the window shatters, what is the difference in opening the door and if there is an air current going through the room? So to test this, we built a room, a small room. We developed a device that we will be seeing this afternoon. It has a vent and a combustion chamber where we can put burning particles inside. We normally use commercial pallets for two reasons. First, because they are very easy to characterize because they all have the same shape, and it is also easy. They are also easy to obtain, very easy to buy. So we built this home with a removable door and a fixed window. From the inside, and from the exposed side, we mounted thermocouples. And this afternoon you will be seeing this, but this was one of our combustion tunnels. And then we have a channel here. We adjusted an L curve to prevent the dispersing of the particles. We have a combustion tunnel, and this is the home here that we have. We conducted measurements not only with the thermocouples, but also using a technique, the PIV, high-speed cameras, and then we also used software that allows us to count all of the particles. This is pictures of the assembly. We filmed, obviously. We also conducted some tests to determine the right type of assembly. We also had the tubes that were linked to the vents. We thought that they would resist, but they also melted. So in the end, we had to take our device, assemble our device on top. And these are the pictures that we took around the room. And we remained outside of the combustion tunnel. We conducted two types of tests, one with particles, as you could see from the device, but in another we removed the particles and we only used wind. Stronger wind, and only with stronger winds it was easier for us to measure pressure, the pressure currents. The door was opened, completely open, half opened or completely closed. These were the three parameters that we used, and we arrived at very interesting results. First, in the measurement of pressure from the projected air. When the door is closed, we have a positive differential of 1 unit from outside to the inside, which means that the pressure inside the room is higher than outside of the room. As soon as we opened the door halfway, the differential is reversed and is multiplied by 6. In other words, the pressure outside is 6 times higher than the pressure inside the room. And with the door totally opened, the pressure continues to increase, but not as much. This clearly indicates the importance of having the door closed or opened. The counting of the particles that entered the house also resembled the pressure measurements. The red and green line resemble the door open or half open, and the black line resembles the door closed. So you can see here that almost no particles enter the room with the door closed, and as soon as we open the door halfway, the number of particles or the particle flow peaks. So this test clearly illustrated what we can expect or what we should do in the case of a fire. So the window may not be opened, but it can shatter in the case of a fire. So having the door open or closed can make a significant difference in the amount of particles flowing into the room. Then we conducted a test with gaps. Any type of gap, it can be a crack in a door, in a window, in the wall, or an open door. So we mounted this structure here, this device that was coupled to a table and a metal plate that you can see here. This is not glass. And we had gaps ranging from half a centimeter to 5 centimeters, and we used artificial pellets. These are pictures of some of the tests that we conducted. Some of the particles hit the plate and are projected. We noted some information. And the main two conclusions that we can draw from this is that between half a centimeter and pellets are 4 millimeters thick. So the opening was 4 millimeters, so a minimal gap, and even then, particles came in. And between the range of half a millimeter and 3 centimeters, there is a significant increase in the amount of particles entering the home or the room. So from 3 to 4 centimeters gaps and all the way up to 80 centimeters doesn't make any difference. So to have a window 3 centimeters open or 5 centimeters open doesn't make a difference in relation to the amount of particles going in. The trajectory of the particles is slightly descending, and this means that regardless of the size of the gap, as long as there is a gap, particles can come in. So the main conclusions that we can draw from these studies is that PVC melts and therefore doesn't offer much resistance. 150 degrees Celsius is the minimum temperature for PVC to start melting. Wood, we cannot be sure about the level of resistance of wood. We simulated wood shutters using pine wood, and we did not use treated wood, which is not the reality because normally wooden shutters use other types of wood and are treated. So we cannot be sure about up to what level of temperature wood can resist to fire. So the combination of glass and aluminium shutters can offer the best resistance to fire attack. as long as these materials are in good conditions. I've already mentioned this. Indoor doors being closed or open influence airflows passing through the home, and gaps, even if they are very small, very narrow. For example, in summer, sometimes we have our windows slightly open to let fresh air come in. But even if the gaps are very narrow, particles can come in. So, from a certain breath, it is irrelevant whether the windows are half open or completely open. We would still like to conduct further tests and test other materials and other parameters like the resistance of windows and shutters to fire of higher intensity. If the windows or the shutters are submitted first to fire and then to water during the extinction phase, we would like to conduct tests with increased flows of particles, and also to conduct tests on different types of structures, like wooden houses. Increasingly, we see communities using wooden houses, garden shelters also that are sometimes made of plastic materials. And I end here within the time allocated to me. And I believe that we still have 5 or 10 minutes to spare for Q&A. Thank you very much for your attention.